Okay, now we will start graphs of motion. So what kind of graphs we are going to study? So first we will see the VT graph, then we will see AT graph. Okay, we will see the graphs of motion. So different type of graph first we will see. So what are the different type of graph? VT graph, the velocity time graph, AT graph means acceleration time graph, VS graph. VS graph is what? Velocity and displacement graph. Then we have AS graph, acceleration and displacement graph. Apart from this, we also do the position time graph. This is the main, the first graph we will learn, the position time graph. Then I have written VT graph. The VT graph can have two different meanings. One, we also represent VT graph for velocity time, and we also write VT graph for speed time. So both of the graph can be drawn. Okay, so first we will see for ST graph. We will start with ST graph. This is ds by dt. So slope of ST graph, what it will give? Slope of ST graph, it will give the rate of change of position or rate of change of displacement, that is called velocity. So slope of ST graph gives the velocity, and area of ST graph, it does not give any physical quantity. So area, we do not find generally the area of ST graph, we are only concerned with the slope. So we will see different kind of ST graph. So first is body at rest. So body, if you consider body at rest, then what will the position should be? What? Constant. Position should not change with time. So velocity is 0, then position should not change with time. So you can see this red line, this is horizontal, which time the S is not changing. Second, if you see body in uniform motion, so uniform motion means constant velocity. So you can see S is changing uniformly with time. So uniform motion means what? Constant velocity, and constant velocity means we have studied slope. So constant velocity means constant slope, because velocity is the slope. What kind of curve? Constant slope is for straight line. So that's why we are getting straight line. Straight line in ST graph indicates, you can see the slope also. The slope is along positive direction. So positive direction slope means what? The velocity is positive. Final displacement minus initial displacement by time. Graph for uniformly accelerated motion. So consider this example, the first one. See, this is the graph. See, here the slope is 0. You can see at beginning slope is 0. As you are moving forward, the slope is becoming more and more. So what does it mean? It means velocity is 0. Slope is 0 means velocity is 0. Velocity is 0. As you are moving forward, velocity is increasing and increasing. So what does it mean? It means there is a constant, there is an acceleration, and the velocity of particle is constantly increasing. And initial velocity, if you see I have here written u equal to 0. So u equal to 0 at t equal to 0. What does it mean? The velocity is 0 at time t equal to 0. So you can see here the slope at t equal to 0. How much is the slope? Is it 0? Slope here is 0. So 0 slope means 0 velocity, and position S is also 0. So you can see it is starting from origin. So S was also 0 initially. Now if you look at the second graph, you can see it is also uniformly accelerated. The slope is changing with time, but initial speed, you can see the initial slope is not 0 at this place. At this place initial slope is not 0. At this place you have some slope. There is some non-zero slope here. So that's why I have written u is non-zero. And displacement is also non-zero. Because why displacement is non-zero? Because it is starting from some height. It is not starting from origin. So it is at some height. So these are the two graphs for uniformly accelerated motion both. But in first case the particle is starting with 0 speed and from 0 position. In second case particle is starting with non-zero speed. So slope was non-zero initially and non-zero position as well. Okay. Next we will see uniform negative accelerated. So you can see this graph. See, initially slope is positive. Slope positive means velocity is positive. As you move forward, velocity is becoming less. The slope is becoming less. And at this point t naught, the slope is becoming what? 0. Slope is 0 means velocity is 0 here. Now the slope is negative. Slope is negative means velocity is becoming negative. And negative, negative, negative. Finally, the velocity is negative in negative zone. So velocity was positive, then 0 and then negative. So what can we say? We can say that acceleration is negative. Velocity changed from positive value to 0 to negative value. Okay. Next we will see VT graphs. Velocity time graph. So velocity time graph, first we see what does its slope say. What is the meaning of slope for velocity graph? So slope of velocity graph will be what? dv by dt. And dv by dt is what? Acceleration. So slope of velocity time graph gives acceleration. And what about area of VT graphs? Area of VT graph gives the change of position. Area means what? Integration. Area means what? Integration. So integration of v with respect to time, integration of velocity with time gives the change of position or displacement. So the conclusion is slope of VT graph is acceleration and area of VT graph is displacement. Next we will see for uniform motion how the graph looks like. For uniform motion you can see velocity is constant. This is the positive velocity because velocity is on plus side. But velocity is not changing with time. It is a uniform motion, the constant positive velocity. Then we see acceleration positive constant and u is 0, t is 0. So you can see velocity initially is 0 and it is increasing at uniform rate. Uniform rate or constant rate. So acceleration is constant, positive constant because it is increasing. Next graph we will see is initially velocity is non-zero. Here the velocity was 0, but in this case, last case, velocity is velocity is not negative, it is still positive, but it is, let me correct it. This is still positive. Acceleration is still positive, but the starting point is not 0. The velocity was initially not 0. It was starting with some initial velocity. Okay. Now move to next one. Constant negative acceleration. So constant negative acceleration, how will it look like? It will look like this. The velocity is decreasing. And velocity is decreasing to 0 in this particular case. Okay. Next we will see acceleration time graph. So what is acceleration time graph? dA by dt. So dA by dt, the rate of change of acceleration is called jerk. And this quantity we are not going to study in detail, but you can just know the name for this for information. Rate of change of acceleration is called jerk. And the area of AT graph is what? That gives the change of velocity. Area of AT graph gives the change of velocity. Now we see the graph for constant positive acceleration. So for constant positive acceleration, graph will look like this. This is constant and positive. Constant negative acceleration. So graph will be on the lower side. Constant negative acceleration.